All right, so a couple weeks ago or a month ago, we learned about how to create a box in Toolpath on different sides of this cube. And today we are going to take a look at how to create toolpathing to be able to cut out just a 3D object. I got this 3D model just from Thingiverse, downloaded it and imported it. So we're going to see how to import into Fusion 360 and then look at some of the toolpathing capabilities. But before we even get to that point, I'll just do a quick review of what we did, a couple weeks ago and what we have in the recorded session of session number 1. So just going to go ahead and click a new design. Going to go into design, created a sketch, and on the top view, we drew out a rectangle and entering in the size that we want that rectangle. At this point, we could take that, extrude that in the upward direction by whatever dimension we want to specify. We then used a side view of that cube to create another sketch on the side, went in, created a circle or any object on that plane, finish the sketch, do the same thing of the extrude or cut. And this time it's going to cut in a negative 0.5. That was our finished model. We then moved from our model into the manufacturing tab. I'm going to close down our view here of our files by clicking this button that just kind of opens up the screen a little bit more. Going from design down to manufacture. And then in the manufacturing, the G right here is where we select the post that we're going to be using. Again, this is all seen in more detail in the first video. Then we need to come down and create a new setup. And this new setup is where we're going to 0, X, Y, or Z in relation to the model or the stock. Coming over and selecting the stock size by just selecting the offset from our model, or we're able to set an exact box size. Once that is set up, we went in and did some two-dimensional pocketing items. Come in and select the tool from the tool database. I'm just going to randomly select one that might already be in here. Say okay to that, selecting the face that we are going to select for tool pathing. We set up our tool heights in dimensions, which we can see that that is from the top down, which is not what we want. So on the geometry, we have the tool orientation. We will go ahead and select the XY axis to be the face. Sorry, again, hung up. There we go. Finding the right one, select Z axis plane. So I selected the face, and we could see that the little trident changes. So the arrow that the Z is pointing, the Z is now coming in from the right side into that hole. Going to the geometry, selecting to cut the inside, we see the cuts change. And simply go okay. And the issue there is the drill bit, that the tooling that I have selected. But that is the basic steps of creating the toolpath. And again, more detail is seen on all of that in step 1. So I wanted to just review the main thing here of how we went in and set up the post processor. and then created a new setup. So with that review done, let's jump into clicking on a new model by either clicking new or coming up and just clicking the plus for a new design. And I'm going to import or insert a 3D model. So if we go to insert, and it is a meshed file. And from Thingiverse, I had several versions. I don't quite know what all the versions are, and I didn't look at them, but you know, the VW Beetle Good sound like the best one to choose because good, why would you not? So go ahead and select that one, and it brings it in. We could now kind of move this around in our XYZ planes. Really doesn't matter where it is coming in at this point, because I'm going to kind of even move it around a little bit more because you know the size is probably way out of whack, size not right, and we're going to scale this. So just bringing that in and selecting OK now brings us into the model. To get an idea of the size of this, I'm going to sketch out and use a construction plane or sketch out a rectangle using it as a construction line. That is done the same way as creating the sketch as we did for extruding the box, only we're not going to extrude this. So I'm going to click on create a sketch. I want to create it on the top view, and we'll use this draw 2-point rectangle. I clicked the 0, 0 location and just going to drag that out, and we could already see that that's fairly large. So we're going to bring that down, just enter in 6 inches. And I'm not real concerned about the Y value because I don't know what it is. I just know that I want this model to be no greater than that 6 inches. So that's kind of given me a bounding box to be able to see the scale of it. Also want to set those lines to be a construction line type. It's easier if we would have done that before I drew the rectangle, but to change that, you can see I just held the shift key down, went around and selected each segment of that rectangle, and going to come over here and click the line type for construction. We'll see more construction line planes and drawing on planes, so I'll make sure I remember, or I will do my best to remember to click that button first to show how that's done. So with that done, I'm going to go ahead and finish the sketch. And we see that this model looks like it is a full-scale model of a car. It is, quite large on the screen. We want to be able to reduce that. Moving allows us to move this around. You can see the cursor change there to where we are moving that around. And if you get completely lost in here, as I just did, we will always have to figure out a way to get back. Now I'm beginning to think my computer is not keeping up. So if all else fails, we're not too far into it. I'm going to click Don't Save. We'll see it all over again. So again, insert a 3D model, cancel, bring the drop-down box and select a insert to mesh. Running that Beetle Good, selecting open. Just going to kind of shift that off to the side, select OK. Going to create a draw sketch on that plane right there. And this time I'm going to remember to first select the option box there to create the construction line sketch. Drawing that out to be 6 inches. And again, not worried about XY. We'll finish this sketch. That now gives us at least an idea or a little bit of a scale. I suppose we could also use the boxes that are listed here if we knew what those were scaled out to. But I do like to have like construction lines just so we could get a more in-depth view of what this is going to look like. So again, we're going to start off with clicking move. I'm going to rotate this around to 90 degrees. To first select the model that move and rotate. There we go, 90 degrees. And then enter completes that, a rotation. Then under modify, there is a scale. We are able to scale this, again, have to select the model, and it's by percentage. So I'm going to guess that 0.125, and then enter. With that scaled, I'm going to go ahead and click move. And move that down into a more manageable position. And I could see that I also am going to need to scale it again. So again, under modify, scale, selecting the object scale. Now there is this little arrow and it gets difficult to scale down dragging this just because it's finicky. So just if you have a very sensitive mouse, it's hard to really control that. But scaling that to a more size to what we want, go ahead and position that again. Now into an area that we're going to want to cut. So I could take it down and scale it down a little bit more if I wanted to be within the 6 inches, or if I just knew that I had a little bit larger material, we could come in here and edit the sketch. And change that sketch to 9. Not quite sure why the beetle is back large in that version view, but there it is. Brings us back down into where we are. So now we have an idea of the size of the model we're working with. And now it is going to come time to start thinking about tool pathing and seeing where it is in space. So according to the top view, it's looking like we are pretty decent around 0, 0. It's not something we have to do, but I like to have it sitting within the model. See, right now it's way up here in the Z-axis. So I'm going to bring that back down. It's not something that we would have to do because when we set up the setup for the manufacturing, we are able to specify where the 0, 0 of the machine is that is separate from where 0, 0 is in the design modeling side of Fusion. But me personally, I like to have at least close. It makes, zooming around and orbiting a little bit easier. So again, I'm going to just bring it down into closer to where 0, 0 is of the design. So before we get too far into it, just so in case I mess something up at this point, I'm able to easily revert back to where we are now. So with that model saved, we want to be able to create tool pathing for this. And that is done under the manufacturing tab or the manufacturing workspace. Currently we're in design, and then we're going to jump down into manufacturing. And again, we have the G here is for the G code or grouping toolpaths. But that is where you select the post processor, where the default names are. We're able to specify that later. We do have to have the option checked for 5-axis. The gauge length, this is the distance from the center of the rotation of the B axis to the end of the collet. You have that number found in SB parts folder, custom folder, then the My Variables file. Again, more detail on that in the first video. This is the retract distance, kind of the safe height for where it goes for any kind of positional moves. And the program feed rates is what it is. So the units is the document units, currently in inches, but if you were designing in metric, we would output this as far as the manufacturing side in inches, because the machine out in the shop there is set up and configured to run in inches. So once you have that set up, we will come in and click a new setup. And this is where we set up the model size or the material size that we're going to be cutting, and where we plan on setting X and Y 0. Typically on a CNC, it's going to either be the lower left corner, either bottom of material or top of material. 5-axis machining doesn't always follow those rules because you have a pedestal that you're going to set your model on top of. A lot of folks will model in that fixturing, or they know where the top of that fixture is relative to where maybe their table 0 is. Maybe one operator may always zero X and Y way over here to the left side of the screen. That's possible. You could do that. It really doesn't matter. But for keeping it simple to what you are probably already familiar with, we're going to set X and Y 0 to the lower left corner. One of the reasons to think about where you're going to set 0 rather than the top of the material, if we have tool changes within this model, one, we might do a roughing that completely roughs out the size of this model. Then we are going to need to follow the finishing. You may not necessarily be able to have and get that 0 because the top of that material has been removed in the roughing toolpath. So think about where you're going to have the X, Y, and primarily Z zeroed when setting this up, thinking or knowing that where it is for the roughing, that same location of the material may not exist after the roughing has been completed. So setting that to the lower left, that's the model orientation. Everything else is looking good. This is where you can change and rotate around. We already kind of handled that in the design space and moved this down to where we would want it to be by rotating and scaling down. The next checkbox or tab here is for the stock. And Fusion in its tool pathing in the setup and in selecting the tools and working through the operations are done organized in different tabs. So one tab, start from the left, kind of scroll down through, making sure everything is set up the way you would like it, moving to the right to the next tab, and kind of working down the same exact way. Currently, we have the model set to a relative size, meaning that it is going to be, in this case, 40 thousandths bigger in the X and XY, and offset to the top by 40 thousandths in the Z. We could also set that to a fixed size. And currently the fixed size in the X is 8.5. Y by 3.5 by 3.5. So what this is saying is for us to be able to cut this, we need to have a minimum size material block of 8.5 by 3.5 by 3.5. That is the exact size of the model that is fitting here. If you really need to have that bigger, because to cut that out, your zeroing has to be absolutely perfect to make sure that we capture all of the model. So we are going to just go maybe a 1/4 inch bigger all around. So we'll set that to 0.75, 75, and 75. And now we could see that model is really an 1/8 of an inch inset, all 4 sides, except for the top is really a 1/4 inch deeper. Well, no, I'm sorry, it is not. So we have the model position centered. We are able to position that at different model positions. Offset that by 0. And we see that shifted down to the top because I have it set position from top. We really would want that positioned 0 from the bottom. So the bottom of our material now is set to the bottom of the model. And we can see that we are up kind of in the air a little bit above the designed space 0 plane. But that is okay because our XYZ for the machining is also up to the lower left of our material block. The next tab is the post-processor tab. This would be the file name. Again, not a whole lot we have to do there, just clicking there to show you, because we will have the option when we post out to save to a different file name. So at this point, we would say, okay. And just, I always like to go up there and hit save. You could put different version descriptions, but really just say, okay, let it be what it is. Okay, so we are ready to think about toolpathing and approach angles. We're going to start off fairly simple, and if time allows, which I'm not certain it will, and it may be getting too complex for this session, because this is the introduction to just being able to bring in a 3D model and set the toolpath. We may just simply approach this from a couple different angles that are already kind of preset for us, rather than setting up new construction planes. Might give a little bit teaser on our next session on how to get more detailed in getting different approach angles. So basically, the toolpathing is going to work exactly as we did with toolpathing the cube. We were using the 2D operations. This time we're going to be using the 3D operation. So 2D basically goes around a selected face or object and goes to the depth. The Z sets that depth, and that's where the Z stays as XYZ, or XY does its milling. For a 3D operation, we are able to set the approach angle just as we are able to do on the 2D, only for 3D, it sees the model and it is going X, Y, and Z, makes its motion around, similar to a dot matrix printer would be, to create the 3D modeled shape. So the first one, to keep things very simple, we'll do a little bit of toolpathing straight down from the top. And we are going to look at the 3D operations to see what ones we have here. The ones that I use, I think the majority of the time, is the parallel finishing. There is a pocketing clearing that we could take a look at maybe first, because we want to clear some of this material out of the way to just make room for different approach angles. So the first thing, we will come here and click the clearing, and notice that we have here the Z is pointing up. That means that the Z approach is coming from the top down. The first thing we'll do is come in and select the tool. Going through the tool database, again, the first video shows a little bit more in depth on what it is, but with the 5-axis, this overall length right there is a critical number to be able to do the different operations. That number, or the tool length, is what is used to know how much to offset the X or Y, or X, Y, and Z to still get and know where the surface of the model is. I'll try to point that out the best I can when we get some tool paths calculated. So going to select that 1/4" end mill. And for real life, I would probably use a ball nose. Maybe for the finishing, sometimes you might be able to do a end mill for roughing to get material out of the way a little bit faster. So with that tool selected, we see all the RPMs, feed rates, and everything still selected here. We will move on to the geometry. This is, what are we going to cut? We have options to do by the silhouette, which is just the model itself. We're able to set a bounding box. And we're able to center that within there. We'll come back and play with different options there. Right now, the geometry is the only one that is selected. We could check off here and we get more options. Being able to select to see what the selections of the stock, that might be what we want right there rather than anything else. So that is good. Our heights is the next step that we're going to look at. The heights is where the cutter is going to go, similar to what we had with that box. Cutting the depth, this might be too deep right now. So this blue box down here, the bottom, that is where the cutter is going to attempt to go and limit itself to that. We want to possibly just move that up because our cutter, and we're going to have some collisions if we try to have that cutter come all the way down to the surface here. The collet itself will probably run into the hood or the bumpers or the fenders of the model as that Z is moving down. So setting that Z plane up a little bit higher will ensure that we are not going to cut any deeper than what that plane is set to. Our passes is determined by, this is what sets how much we're going to allow this cutter to make in a single pass, what directions we're cutting, and all of that. The linking, we're not going to deal with a whole lot there at all. So just so we can see what happens, I'm not going to change any settings. We'll come back in and fiddle with them to see what differences we have. So I'm just going to say okay here. And we now have a tool path that has come down directly from the top down, and we are able to see that it was only cutting to the depth that our cut plane was set to. We do have a simulation that we're able to run. Under setups, simulate, and then just hit play. And right away, I'm seeing something that's, not probably what we want to do. It's going to take forever to cut this out because I don't know what we're cutting this from. Maybe this is correct if we were cutting this out of an aluminum billet or something like that. But for test purposes, first time I would probably cut this in a foam. And you can see it just went around once. It went down a little bit deeper. So there's a lot of passes that are making this up. Not what we really want. So I'm going to go ahead and stop that. Exit our simulation. And we could see each one of these blue lines here is a different level pass as it continues cutting. So we're going to take a look back at that tool path and see what we could do to speed this file up, take a little bit more aggressive cut with it, and just be able to get the job done a little bit faster. So to get this done, going to double click on the tool path right there, come straight over into passes and get a feel and a look to see what is going on here. So the maximum step down looks like a number that is relating to these here. So the maximum roughing step down is 0.025, 25 thousandths. That is maybe okay if, again, we're cutting aluminum, but if we're cutting this out of foam, I'm going to say 0.5 is doable. I got a double decimal there. So I'm just going to change only that number and then select OK and see what changes. And right away, we're able to see that that was different. So we're going to go back, simulate, and hit play and see what that looks like. And already we could see that it is cutting much deeper the first time. Looks like we do have to add some sort of offset to the outside there, because as we come across here, we're going to see some issues. And as that's cutting, you do see that kind of collet moving up and down. That is going over the 3D surface. And this is where we're going to see and have an issue. So if we were cutting this for real, you see that collet turning red there. That red is saying, hey, you've just crashed the machine into your model. So as it's cutting and you're previewing a simulation, if you see this collet turn red, that means that that's not good. Red, not good. And we see the model on top showing red. That is the material that is causing the issue. So again, we're going to exit the simulation and inspect on what we could do to correct that. So again, coming over to the toolpath, double clicking, and that is going to be most likely in the, let's start with the geometry here first. It's a bounding box. The tool containment, additional offset. I think that is what I'm wanting to do. So we're going to do an additional offset of 0.5. And again, changing only that one number and selecting OK. And right away, I could see that, yes, that is now outside of the material. And again, going to right click and simulate and hit play. We can now see it's completely removing all of the material, and we will most likely not run into a collision or a issue with cutting this surface now. Sorry for the pauses, but we'll wait for this one to finish to see what it looks like. So we do see some red lines there. So I said earlier that red is bad. In some cases, red is, but that red that we're seeing there is the machine spiraling down into the cut as a rapid positional move. So that that red is probably okay. I am already seeing again that we may end up with another collision issue, because it is doing what is more of considered to be a Z-level roughing, and not doing any kind of contouring. So we can see the little bump up right here of where the hood and the roof of the vehicle would be. And it's just removing the areas out around that all at one level, which may end up causing a collision, but so far we might actually be okay, because of the round body of the vehicle is offset out enough to where it's not causing a collision. Hopefully we're understanding that aspect of the collision in the Z-level roughing. Yep, there we go. We got some collision right there. So that demonstrates, I think, what I was trying to explain. We could correct that roughing by, or that collision, in a couple ways. One, increase the number of step downs that we have. So we're stepping down in half-inch increments, which means that it's also seeing it in half-inch planes, kind of like a typographical map view of what it looks like, you know, a mountain would look like. And that collet is just, you know, too big to where it hits the ridge of the next elevation. So either we choose to do a different type of roughing, or we increase that step down to provide a roughing that makes this top part a little less aggressive. So let's just try that first. And that is done in the passes. And again, we went to 0.5. Let's change that to 2.5. So the way it does this roughing and the way it looks at it is we're telling it to step down in 1/4 inch increments. So it comes down to a 1/4 inch and just does a 2-axis move around that part and making sure that it is staying outside of that area. So we could see the silhouette of our vehicle within the model, and we could kind of see how it's stair stepping its way down into there. So this model and the way it is stepping down, we might be okay, but we still might have an issue with collision, not because of the step downs, but just the general tool length. So we're wanting to make sure that we have enough tool length here that is able to come down to this full depth or each one of these step depths without the distance of the collet coming in contact with this area here. So if we have a collision now, we cannot, there's nothing a whole lot we're going to be able to do about that within the toolpath settings or the feature toolpath settings. The only thing we could do is get a longer tool length to correct that. So let's just see if that did correct or if we do have any collisions here. So simulate. Just a little bit of collision right there that we had overall. So again, there's not a whole lot we'd be able to do about that. If that is the only cutter length we have, we'd have to go out and buy another cutter. So we do have to pay attention to overall cut length and where that is coming in, and that collision is hitting. We exit the simulation and view it right here from the left side. So that collision is when it, in both sides, coming down to this height right here, this plane right here, the tool length is sitting up and coming into a collision of the side just because the collet is coming in contact with the side of the vehicle as it comes down. So not a whole lot we could do about that, other than maybe approach it at a couple different angles that we might be able to remove first. And that would be adjusting the overall cut depth, that is the cutting heights. Don't allow it to cut as deep. So moving this up a little bit farther. Maybe there, we'll say, okay, that is going to reduce the total number of step downs that we have and only cover more of it, the top side. So with that done, the top side roughing, let's take a look at how we could still use this toolpath to get it done. And now we are looking at the usefulness of the 5-axis machine, because we have the top partially roughed out. Let's take a look at roughing out both the right and the left side. So I'm going to set that to, and actually we're calling it the front and the back. So with that done, let's do the same type of roughing that we just did. That was the pocketed roughing. The same tool is selected. Going to come over and select the geometry. And we've already learned that we do need to have a little bit of an offset. So we're going to go with 0.25. And the tool orientation. Right now, we are coming down from the top side. We want to come in from the front, or the way the view is pointing to the passenger side of the vehicle. And to do that, we are going to attempt to just do it by the front, and then come to the tool orientation and see if we could say model orientation. That did not do it. So I'm selecting the Z plane. And what we have are, just as we did on the sketch, when we select the Z plane, we see these 3 planes. That's the XY different planes. So we're going to orient it to this plane right here, selecting that. We see the Z is now coming in from the driver's side, but we really want to have that from the opposite side. So let's just rotate this around to 180 degrees, or the minus 180. And we are now making the approach coming in from the Z plane. The next view is going to be our heights, just as we had it earlier. The blue is how far down the Z, or the machine, is going to come into the cutter. What we've really done is kind of reposition the model to where it's positioned this way, thinking that the Z is coming down here, which in reality is the Y-axis that's been rotated, has the head rotated to come in. So basically what we're kind of setting up the machine at, and this is where 3 + 2 machining come into, we're kind of reorienting behind the scenes the X and Y values. So anyway, just going to bring that plane over to where we're going to just barely catch the side of the vehicle there. Maybe get it. And we're snapping in here. And as we move around the bottom height, we see an offset coming from 3 to 2.5. That is down in this location here. So I want to go in between that value. I'm just going to set the B.2.75, and we see that that shifted to that location right there. So I'm going to be pretty certain that's okay on the clearance heights, the passes. Again, we already know about that roughing size, so let's take that to 1/4 inch. Similar to what we did from the tops down view, and let's just go ahead and click OK to see what this looks like. So we have now two toolpath operations, one pocketing that is down from the top, and then another one that is pocketing in from the side. Again, let's do a simulation on all of this. And we can see that is how the head would have rotated in the process. So we are not seeing any red lines within the on the model itself, other than the red helical moves ramping into the material. So that is looking okay. And we might want to even think about, we could have maybe cut the sides first, then coming into the top, which would allow that top to cut a little bit deeper. So before we kind of get into time, we will just take a look at finishing the toolpath on both of these surfaces. So that is two roughing toolpaths. We are now going to take a look at a finishing toolpath in the same way. So I'm going to exit this simulation, and coming up into the 3D view, let's go ahead and do a parallel finishing. And we are oriented back to the top side. We see the collet here. The tooling, I'm going to leave still a 1/4 inch. We may want to think about doing this on with the ball nose, but we're able to simulate and see what the overall finish looks like. End mills sometimes work well for 3D finishing as well, as long as we have the tip that's staying somewhat normal to any kind of surface contours. So the geometry, again, we will come in and, well, in this case, we don't have to do an offset because we've already roughed out two sides, but in reality, we would have gone through that same process to do all sides. The heights, just as in with the roughing, we could bring that height up to where we think we have enough tool length to still be able to get down to that. And remember, our roughing was only done up to that point, which could be just fine, because we're now going to finish here, and our finishing bit will remove the rest and act as the rest of the roughing. Number of passes, again, this is, let's see what we have, our pass direction, good at 0, step over. This is typically you'd want 10% of the diameter of the cutter. We're better than that, so we're actually going to get a smoother finish, and it will take longer to run. The cut height, let's see what that is all about. Direction both ways, up, down, multiple depths. Yeah, we don't need to have multiple depths, just one is fine. So go ahead and click OK to see what we get. So that is our finishing toolpath. Let's see how well and smooth of a finish we get by simulating. So we could, a couple things to do. One is to increase the step over, or decrease the step over to get a smoother finish here, or change the bit to a ball nose a bit. Also, I think we would need to create the step over, getting that much closer together. So the step over is going to be how smooth or detailed of a finish. I shouldn't even say detailed because the bit diameter determines the detail. But the step over is how much it steps over before making the next pass. We are approaching an hour here, and there was a lot to cover in this video. I think we need to do another session again to expand on what we did here, but this is kind of the basics of creating tool paths for a three-dimensional surface. We only did the roughing for the top side, the left side or passenger side. The same way we did the passenger side, we would do the driver side same way, select the front side, back side, and completely rough out before moving on to any of the finishing tool paths. I think what we will talk about in the next session is how to create cutting planes that are not already set. So for this windshield, we may not want to cut completely in from the right side, don't want to come in, horizontal. XYZ might need to be angled, coming in from the top right at the same angle that the windshield is. That might give us a smoother, better cut. That will take us probably our next session, in session 3. But I don't want to be done now because I want to hear any questions that you have. So if you have a question, just go ahead and ask.
I don't think I have any questions. I just wanted to say that was extremely helpful, seeing you move the Z plane up, because that one kind of boggled me just looking at it before and watching videos. So I think once I actually try a model, I'll discover lots of questions for you. But that was really helpful, Ryan.
Yeah, hopefully once you, a lot of this, what we're showing is it's not really fully understood until you complete the entire process and break a bit or crash the machine. And that's when you say, yeah, okay, now I understand what that depth was really about.
Yeah, I could, I've done a little bit enough to know, like, understand what you were talking about the crashes and stuff. It's like, oh yeah, you can see the collet will hit that part. But it was really helpful to see it laid out so clearly, because it's like, even if I had never seen it before, I go, yep, I understand. But you're right. Once I get in there, I think things will really start to crystallize.
Wonder, Ryan, is the exact collet that we have for our machine available in Fusion 360, or do we have to like model it if we want the exact collet?
There is modeling and sizing. What I might have there may not have been the exact model of it, but you can change the sizing of the collet within the tool database when selecting the tooling.
Under holder, maybe?
Yeah. Yeah, that's where it would be in here. The holder is an inch. It's an ISO 30, ISO 30. But there are ways, and I think one of our last sessions we'll look at how to bring in it's quite fun to watch and do it, because we are able to bring in the entire model of the 5-axis machine. So in the simulation, not only are you seeing the collet moving around, you are able to see the entire XYZ gantry spin and rotate and do its thing. But that's I don't want to confuse that until the end, until you guys have actually cut, because it's a little bit complicated getting that all set up and working.
Cool.
And how much would a ball nose affect machining? Like as far as step over, especially.
It depends on the geometry. So looking at the profile of this vehicle as we have right now, if we machine this with an end mill, starting from the left, coming up and over and down these curves, the difference in finish that you're going to see, end mill versus ball nose, the end mill is actually going to probably give you a smoother cut and a better looking finish than a ball nose would. But if we were to run the end mill, not up and over, not front to back, but from passenger side to driver side up along this contour, then that would be the opposite effect, because what we would have, and we would see little stair steps of that end mill across the flatter section of the hood and across the roof. We would get a smooth finish. But it kind of depends on the geometry that you're cutting and the directions, the angle and the approach angles that you're cutting kind of determines that what's going to give you the smoother finish.
Got it. I think that's all the questions I had.
Yeah, me too. Thank you, Ryan. That was
Yeah.
really great.
Yeah,
You're
thank you.
welcome.
That was helpful.